Hello, my dear students, dear viewers, Assalamu alaikum. Welcome to Asif sir's classes. Today we are going to discuss the third chapter of physics of class 10th, that is electricity. And in this chapter we are going to discuss two important terms. One is current and another one that is potential difference. This is an introduction topic to this chapter, so please my dear viewers be attentive. So far current is concerned, it is defined as the rate of flow of charge. Current is defined as the rate of flow of charge. Or we say it is the speed of charge. It is the speed of charge. Current is written as current is equal to charge per unit time. Charge per unit time, and current it is denoted by the letter I, that is equal to Q divided by T. And charge, the unit of charge, that is coulomb, and the unit of time, that is second. Coulomb per second, that has a name, that is called ampere. So the SI unit of current, that is ampere. If we have to define this ampere, can say when 1 coulomb of charge flows in 1 second. When 1 coulomb of charge flows through a conductor in 1 second, current is said to be 1 ampere. Okay? Now, there is some convention. There is some convention. Have a look at here. See, suppose this is a conductor. Just have a look. This is a conductor. See, it is X, it is Y. Okay? And here electrons are moving in this direction. Okay? This is a conductor, X, Y. Electrons are moving in this direction. It's a convention. No one can say why. There are a lot of arguments that current will be like this from Y to X. From Y to X. If electrons, what is electron? The electron is charge. If charge is moving from X to Y, it is assumed that current will be from Y to X. Okay? It is assumed that current will be from Y to X, like this, from Y to X, in this direction. So we can say the direction of current is opposite to the direction of flow of charge. The direction of current is opposite to the direction of flow of charge. Just have a look. If electrons are moving in this direction, and current is moving in this direction, opposite to this, that is why some people says that current is the flow of positive charge. But that's not true, that's wrong. Current is the flow of charge. You don't have positive charge and negative charge. You have charge. Current cannot be defined on one charge. Okay? Current is the rate of flow of charge total. Okay? Just have a look here. We have a little bit question. If any flows from A to B in t seconds, find I. That means current. If E is equal to 1.6 into 10 to the power minus 19 coulomb. What is any? Any means n number of electrons. Have a look here. Any n number of electrons flows from A to B. Any n number of electrons flows from A to B in t seconds. We have to find current. And here E is given, that is equal to 1.6 into 10 to the power minus 19 coulomb. We may write I is equal to Q divided by T. That is equal to, here Q, that is charge. Here charge is electron, but how many electrons? That is n electrons. So I may write n into E. E is given, the charge of electron, that is 1.6 into 10 to the power minus 19 coulomb. Divided by time, that is T. Okay? And in physics, 1.6 to 10 to the power minus 19 coulomb, that is represented by the letter E. That's the basic charge. Okay? I may write it here. N into E divided by T. Okay? That is I is equal to NE divided by T. We have another formula for current. That I is equal to NE divided by T. That's I is equal to NE divided by Okay, is clear? Now, there is a conceptual term. Just have a look. Just have a look. Interesting topic. See here. If 5 ampere of current is flowing in this direction, okay, and 3 ampere of current is flowing in this direction, what will be the current in this direction? Just have a look. If 5 ampere of current is flowing in this direction and 3 ampere of current is flowing in this direction, what will be the current in this direction? Just have a look. My dear viewers, just have a look. Remember, at any junction, junction means this point. At any junction, junction means this point. At any junction, net inward current, that is equal to net outward current. I will write it here. Net inward current, that is equal to net outward current. Okay. Net inward current, that is equal to net outward current. And inward current means current coming towards the junction. Current coming towards the junction. Just see here. 5 ampere is coming towards the junction. 3 ampere is coming towards the junction. That is, this is the total inward current. Okay, I will write it here. That means inward current, net inward current, that is equal to 5 ampere plus 3 ampere, that is equal to 8 ampere. And this net inward current, that is equal to net outward current. Outward current means the current leaving the junction. This is the current leaving the junction. That means here current will be 8 ampere. That means here current will be 8 ampere. Okay. But this principle says us that current is not a vector. This principle says us that current is not a vector. Vectors are not added like this. Scalars are added like this, but vectors are not added like this. No doubt, current is magnitude, current has direction, but still current is not a vector. That means everything having direction does not mean it's a vector. It is not the definition of a vector. Okay? The definition of vector is something which follows vector law, and vector law is something else. Okay? Vector law is something else. That is, we can say current is, there is another term for this current, that is, current is a tensor quantity. Current is a tensor quantity. Okay? And if you have options, if you have MCQ, that's multiple choice question, that current is scalar, vector, both, none, then you can write current is a scalar quantity. If there is no any option of tensor, then you can write current is a scalar quantity. Okay, is clear? Now moving ahead. We have another term, that is potential difference. That is potential difference. Just have a look. Potential difference. Before moving ahead, my dear students, dear viewers, I may remind that if you have not subscribed to my channel till date, please and please subscribe my channel so that you will get more and more useful lectures. Moving ahead, potential difference. As you know, heat flows from higher temperature to lower temperature. Isn't this? Heat flows from higher temperature to lower temperature. Does water flow? Yes, of course, water flows. Water flows from higher height to lower height. That means everything that flows requires a difference. Everything that flows requires a difference. Just have a look. Flow of heat requires temperature difference. Isn't this? Flow of water requires height difference. And same is the case here. Flow of current requires potential difference. Flow of current requires potential difference. If there is potential difference, current will flow. If potential of two bodies is same, current will not flow. Current will not flow. Just say we say here, we say if temperature of two bodies is same, heat will not flow. If water level of two bodies is same, water will not flow. Just here. If potential difference is there, then flow of current will be there. That means flow of current occurs potential difference. Now what is this potential difference? Just have a look. Potential difference. To understand potential difference. To understand potential difference, I will take here one term, that is unit positive charge. Unit positive charge, that is plus 1 coulomb charge. This will help us in understanding potential difference. Just have a look. Unit positive charge. I will take here 2 points. Say suppose it is point A and it is point B. Have a look. And at point A, I may take plus 1 coulomb of charge. Okay? And this plus 1 coulomb of charge, I am bring this from point A to point B. I am taking this plus 1 coulomb of charge from point A to point B. Okay? That means we can say plus 1 coulomb of charge is running from A to B or is made to run from A to B. When we are taking this plus 1 coulomb, we are pushing this charge. We are pushing this charge. We are pushing plus 1 coulomb of charge from point A to point B. Okay? When we are pushing this charge, we are applying force. We are applying force. We are doing displacement from A to B. We are doing work on this charge in moving from point A to point B. And this work done on this charge in moving this from point A to point B is called potential difference. It's called potential difference. So we can say potential difference is the amount of work done on this plus 1 coulomb of charge in bringing this charge from point A to point B. Okay? To define potential difference, I may write potential difference is the amount of work done. Is the amount of work done in bringing a unit positive charge. A unit positive charge from one point to another, from point A to point B, from one point to another point. This is potential difference. This is potential difference. Just have a look. Potential difference is denoted by the letter del V. There, that is difference. V is potential. That is equal to work done divided by charge. Okay? Just have a look. Work, the unit of work, that is joule, and the unit of charge, that is coulomb. Joule per coulomb, that has a name, that is called volt. Okay? So the SI unit of potential difference, that is volt. The SI unit of potential difference, that is volt. If we have to define this volt, can say when 1 joule of work is done on 1 coulomb of charge, that potential difference is said to be 1 volt. Okay, we can define potential difference. We can define 1 volt of potential difference. We can say potential difference is said to be 1 volt. When 1 joule of work is done in bringing a unit positive charge from one point to another point. Okay, this is potential difference is said to be 1 volt. There is one more term, that is potential at a point. That is potential at a point. Potential at a point, or I may say it's at a given point. This is also called electrostatic potential. Just have a look. If to understand this point, I will also take here plus 1 coulomb of charge. Just have a look. I will take here point A. We have to say suppose we have point A. Okay, we are going to find. We are going to find the potential of this point. Element. Okay, and what we do? We set a point at infinity. We set a point at infinity. Okay, and at infinity take plus 1 coulomb of charge. Take plus 1 coulomb of charge, and take this, bring this plus 1 coulomb of charge from infinity to point A. To point A, when we are taking this plus 1 coulomb of charge from infinity to point A, that means we are doing work on this charge. Okay, and this work done from infinity to point A is the potential. is the potential at point A. Is the potential at point A. I may write it. Work done in bringing plus 1 coulomb of charge or unit positive charge from infinity to point A. To point A is the potential at point A. Is the potential at point A. Just have a look. You will understand it easily. Here, plus 1 coulomb of charge is moving from this point to that point. Okay, that means this is initial, this is final. If we have to find potential difference, that is del V. We know del V, that is equal to work done divided by charge. Del V, this is the difference potential. That means final potential minus initial potential. I may write it VA minus V infinity. Okay, that is equal to work done. Work is done from infinity to point A. That's work done. That is W infinity to point A divided by charge. That is 1 coulomb. Okay. Just have a look. VA minus V infinity, that is equal to work done. Work is done from infinity to point A because charge is at infinity. Okay. Now in physics there's a concept that potential at infinity, that is equal to 0. That means V infinity, that is equal to 0. If V infinity is 0, that is we can write VA is equal to W infinity to A divided by 1 coulomb. And this is the potential at point A. Here you may look, VA is equal to W infinity A. W infinity to A. That means work done from infinity to A. Work done from infinity to A. Okay. On this charge, plus 1 coulomb of charge, that is the potential at point A. At any given point, at also called electrostatic potential, there is a slight difference between the potential difference and the potential at a given point. This was all about the current and the potential difference. Keep watching Asif sir's classes. Thank you. Allah Hafiz.